All right. The table shows the number Y in thousands of alternative fuel vehicles in use in the United States. X years after 1997. That's important because it doesn't start just anywhere. It starts after 1997. Okay. So tell me what 280 would represent. If X, that's definitely your y-intercept. Very good, because X equals 0. And so which means what? What does it mean 280? What does the y-intercept mean in this problem? Um. Okay, one at a time because I can't hear. Miguel, go for it. In what year? No, 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 no. So if it's year 0, is it after 1997? This is the year 1997, and this would be 1998, 99, 2000, right, and so on. 3 years after 1997 would be 2000, correct? Are you with me? Yes. Okay, so that means that when they started this study in 1997, because that's 0 years after 1997, there were 280,000 alternative fuel vehicles, all right? Now there's a lot more because it's becoming a solution for what? For pollution, right? Moving away from gas and going to other alternative fuel vehicles. We got it? All right, so the first step that we need to do is we need to go ahead and graph it, okay? So this is a ballpark because it's a scatter plot. It doesn't have to be perfect, okay? So 0 and 280. Somewhere over here? Yay? All right, 1 and 295. 2 and 322. 3 and 395. 4 and 425. 5 and 471, correct? Oh my God, I graphed this wrong. This is supposed to be over here, right? I'm sorry. Okay, let me go back. I'm not doing this right. All right, so 0 and 280, that's correct, right? 1 and 295, that's correct. 2 and 322, that's correct. Oh, it was just that one. 3 and 395. 4 and 425, it should be a little higher, right? Like in the middle. 5 and 471. 6 and 511. And 7 and 548, okay? Then after that, you're going to make a trend line, okay? So a trend line, and you're not going to have rulers on the test. Right now we're using a ruler, but you're not going to have rulers on the test. What you do on the test, if you take that, you know, that extra piece of paper that they give you, and you fold it, and you use one of the edges as your line, okay? So what you got to do to make a trend line, and I think we did this a little bit during summer, is you need to find a line that hits most of the points, correct? You remember when we did this or no? Yay, during summer, if you were here during summer. That's why summer is so important, because we really do cover a lot. Where's my black mark Sharpie? All right, so get your rulers out. Oh, here it is. All right. And then we're going to go ahead and make a line that kind of hits most of those points, okay? Are we good, my babies? All right, so now I want the equation of the line. So where can I go to, or how can I figure out the equation of the line? Very good, just go to stat. Very good. And you got your x's, 0, 1, 2, 3, 4, 5, 6, 7, and you got your y's, and you can do your thing. If there's somebody in your team that does not know how to do it, please help them out. Because there were some people today on the test that were struggling with that stat. Okay, so you go to stat and you write down your x's and your stepwise. So it's 0 through 7, 280, 295, 322, 395, 425, 471, 511, and 548. And then you go back to stat, calc, yeah, don't say. 4, and then all the way to the bottom, right? So y equals, we can round, it really doesn't matter. It's probably better to round. So what's my slope? So 41. Very good. We're going to round. And my y-intercept would be what? 263? 263? You can round. It's okay. All right. So my equation would be 41x plus 263, which is very close to that 280, right? But remember, this is a line of best fit, so it's not going to be exactly that y-intercept. Are we good? And everybody knows how to do this, see? So use the equation of the line to fit from the above example to predict the number of alternative fuel vehicles used in the United States in 2010. So what is that asking you to do? To do what? With what? So if it says use the equation of the line of fit, what am I using? Which equation? The equation that we just calculated, right? The equation that we just calculated is the equation of this line, not the points, but of that line of best fit. And it's 41x plus 263. Now it's asking me to calculate the number of fuel vehicles. So is it asking me for x or is it asking me for y? It's asking me for y, which means I have to have an x, right? What is my x? 2010 is my x? What is x? Read the problem at the top. What does it say x is? Years after 1997. So, how do we do this? How do we do it? How do I do it? 2000 and what? Is the x equal 13? Is that what you're saying? How did you calculate that 13? I want to know. X equals 7. How do we do that? How do we do it? Yes. How do we do it? Just tell me how do we do it? Thank you. 2010 minus. Thank you. Ernesto was the only one that I guess understood what I was asking. 2010 minus 1997. And that would be what? 13. Not 7, but 13. Why is it 2010 minus 1997? Why? That's the time what? Because it's the x is how many years after that year. So if you want to figure out how many years is after that year, you're going to take the 2010 and you're going to take away the 1997. And that's 13. Okay, this is the scatter plots have a lot of years and they always have a starting year and the problem always tells you the starting year. Okay, so that's your year 0. That's always your year 0. You don't put on the calculator 1997. You put in the calculator 0. Okay, so if x equals 13, then what can I do? I have two options. What are they? Table. I can go to the table. Very good. And what's my other option? Very good. Or I can say 41 times 13 plus 263. And that's it. Or I can just go straight to the table after I put that equation where? On y equal to. And then I can go to the table and look for x equals 13. There it is. And what's my answer? 796. But these are thousands, right? Yay? How do I know that they're thousands? How does Miss Marie know that these are thousands? It says it at the top, but guess what this STAR test will do? One of them will be 796, the other one will be 796,000. And if you're not paying attention, which one do you pick? 796, okay? But it's thousands. So you got to make sure that you add those zeros. Or you write the word thousands beside it. Are we good? Yay? All right, let's go to the next one. All right. So a line that lies as close as possible to a set of data. It's called what? What is it called? It's on the other paper. What is it called? On the paper that we just passed. A what? Best fit line. Very good. Very good. Best fitting line. Very good. It's a best fit line or trend line. It's also called a trend line. Let's put it over here because sometimes it's called a trend line. All right. Okay, so how do you know whether a set of data shows a positive, negative, or no correlation? So let's start with the positive. How do you know? Very good. The y. Oh, I like that. I like that. What did you say? The x goes up and the y goes up, right? What about when it's negative? The x goes and the y goes down. Very good. The x goes up, the y's go down. What about no correlation? The points are everywhere. It's scattered points all over, right? So points are all over? Scatter all over or just all over? Yay? All right. Tell whether the data has a positive, negative, or no correlation. This one? Negative. Would you say, what would the R be? Close to -1 or close to -0.5? -1. Very good. What about this one? Positive. Close to what? Close to 1. What about that one? It's all over the place, so that would be no correlation. My R is, I already heard it, 0. Very good. Good job, babies. Good job. All right. Tell whether the correlation coefficient for the data is closest to -1, -0.5, 0, 0.5, or 1. So talk to me about number 6. No correlation, so the R equals what? Very good. What about this one right here? 0? Positive 0.5. Very good. Positive 0.5. What about that one? You got to make the line and then you decide, right? If you can make the line and then you decide. So what's my R over here? -1. Very good. All right. So in exercise, we're not going to draw a scatter plot data. We're going to approximate the best fitting line. So how do we do that? If I want the best fitting line. What? You go to stat and you figure out the equation of that best fitting line. Very good. So you go, and then we have to figure out, estimate y when x equals 20. So can we go to stat? All right. So go to stat. I'm not going to do it. You do your thing, because I'm old and I'm tired of working. So my babies work for me. That's the beauty of teaching babies. They're not listening. They're over there talking. Oh, Juanita is, and she's like, whatever, right? Juan? Really? That guy over there. Yes, Joseph. Yeah, take that paper and take that paper. are we good? What's my equation? Y equals what? Okay, so let's go ahead and round. Let's go ahead and make the consensus decision to just kind of round. So can I just say 13x? Minus 1? Oh, minus 4? I'm sorry. Okay, so what is y? So there are two options. You can either plug in the x or you can go straight to the table, right? So when x equals 20, what is y? 256? Yay? Did anybody do the next one? No? Okay, then let's go for it. All right, so we're going to go to stat. I got to go up and clear. What am I doing? I'm not even in stat. Crazy. All right, 1, 2, 3, 4, and 5. All right. So y equals what? Negative 20x plus 141. And then when x equals 20, what is y? Negative 259. Are we good? Yay? All right. Ready for the next one? Can I take it out? All right. Let's go to 15. All right. Which equation best models the data in the scatter plot? First of all, what kind of slope does it have? Can you make a line, first of all? Yes, it's definitely what? Negative. So which one can you eliminate? A. Very good. Y equals 15 is Vox or Hoy? What would this be? This would be Hoy, which means it's a horizontal line, right? That's definitely not a horizontal line, correct? All right. All right, so let's take a look. If you have to, this is a lot of estimation, correct? Now, that doesn't help because all of them are negative. So now I need to go to my y-intercept to figure out if it's going to be 19, 26, or 33. If you had to pick a y-intercept, if you had to pick a y-intercept, if you had to pick a y-intercept, would you pick 19? Would you pick 26? Or would you pick 33? 33? All right. Yes. Tell them to.
And I'll pay you back in the morning. I come back to school in the morning.
I don't know if I have anything. No. Jackie, can you check in my purse? Check my purse. Look for $2. All right, let's go. So which y-intercept, well, let's talk about which one would you eliminate. I would definitely eliminate 19, right? If I extend this line, right? If I extend that line, it's definitely not going to hit the y-intercept on 20. 20 is right here, correct? So it's definitely not that one. Okay. Yeah. Bye, baby. You just put the money on that. So is it going to be, very good. It doesn't go past what? 30. So it's not going to be 33. So I would pick which one? B. Very good. All right, we're not going to do 16, so don't worry about it. That's why it has a cross. All right, let's go for the next one. A set of data has correlation coefficient R. For which value of R would the data point lies closest to a line? Closest to a line. Looking at your R's, which one will the points lie closest to a line? But you need to understand what the correlation coefficient is. I told you this morning, what is the definition of a correlation coefficient? You have it on your notes as well. So go ahead and look for it if we still do not know what it represents. It's not just a number, it has a meaning. Coefficient, correlation coefficient, which is your R. In your notes, in the packet that we're working, it's in the packet that we're just working. Because that packet in the front has some notes, correct? It's how well what? It's how well a line fits, right? And what did we say about -1 and +1? What did we say about -1 and +1? Okay, so when the number is closer to -1 and when the number is closer to +1, what could I expect for those points to look like? Close or spread apart? Close. So which one of those data points lie closest to a line? A, not B. Why would B? That's not even a correlation, is it? How are the points on that one? Everywhere. Thank you. So, and where are they closest to each other? Where they're closest to -1 or +1. So it would be -0.96. Okay? All right, the data pairs X and Y give U.S. average annual public college tuition, Y in dollars. X years after 1997, that's important. Approximate the best fitting line for the data. So I want the equation of the line. Go. I want the equation of the line for that. You need to figure out what is X and what is Y, and it's years after 1997. So what's your, well, you have it on points, right? You may want to do an X and a Y table, because it's confusing that way. What are your X's? No. 0, 1, 2, and then whatever, right? Thank you. It's not a race. You got that right. All right. Let's go ahead and round so it's easier. What is my Y equal to? Do we have it? 78, but I had 100 and something over here. 101. All right, so 101. Who's getting 101? Who is getting 101? All right, so 101x? 2,200 and? Yay? Does everybody agree? All right, so any other questions about this one? Nope. All right, are we good? Are we good? All right, next one. All right, go as a group. This is what I need you to do. I need you to do the scatter plot. I need you to do the line of best fit. So you're going to actually draw it. All right, eyes on me. You're going to make, you're actually going to graph the points. Then you're going to draw the line of best fit, and then I want the equation. Yay? Go. Go, go, go. All right, so this is the number of income in thousands, and that's the number of problems. So apparently, Notorious Big says that if you got more money, you got more problems. Big, yeah. B-I-G, I'm sorry, Notorious B-I-G. Not Big. His name is Big, and he was big too. All right, so let's go ahead and graph, okay? And remember, this is an estimation. It doesn't need to be perfect. So 2 problems for about 94.60. 2 problems for about 11, right? There. 12 for 12 for, wait, 12 is all the way over here. For 34. Am I doing this right? All right, yeah, 71, 19 yeah, because this is your X and that's your Y. They're flipped, right? So you got to be careful. This is your, no, they're not flipped. This is your X and that's your Y. So 71 and 19? Somewhere over there? Did I do the 12? Yes. All right. 30, about 40, and then 13. 5 and 20. Or should I say 20 and 5? About 41, 511. 16, 55, and 16 maybe? Somewhere over there. All right. 1 and 6,000. All right. 31 and 8. 23 and 7. Did everybody do this? This is what you were supposed to do. Okay. So I should be the only one really writing, because you should have done this already. All right. 71 and 20. 80, about 84 and 24. And then 44 and 10. All right. Yay? They don't have to be perfect. We just got to have them there. All right. What kind of what kind of correlation? Positive. All right. Thank you. Okay, let's go ahead and try to come up with a line. Maybe there? Should have been a little lower, but it's okay. All right. Yay? And now we go to stat and put those numbers in there, right? Did everybody have a chance to do that? Let's come up with the... Now, based on the scatter plot, is big notorious big correct? B-I-D, okay, oh my God. It's big. It's big. All right. More problems? More problems, more money? More money, more problems? Yes or no? According to this data, is what he's saying is he correct? Is Notorious Big correct? More money, more problems. Yes, it's a positive correlation, correct? It's definitely a positive correlation. Yes? All right, so what's the equation? Y equals what? We're still working? You got it, Saul? What you doing, Saul? Are we just chilling? Baby, All right, what do we got? 3,300 and? 2,700 and? Is that correct? Hector, did you get this? Let me see it. Oh. You're talking, you're not working. More talking, more problems. You got that right. With Miss Marine. I like that one. I like that. I really like that. Thank you very much. Okay, I need some people to second this. You thirded? Who forts it? All right. Are we good? Yay? Yay or nay? Yes? All right, let's finish this too. And then let's go to the family challenges. May I? All right, let's go. Next one. All right, test scores and time spent studying. What's your X and what's your Y? The X is your test scores? What depends on what? The test depends on the? All right, so which means bottom is your X, top is your Y. So what do I have on X? Time, studying, stop talking, and what do I have on Y? Test scores, right? All right, what's my highest and my lowest on my X and my Y? Let's start with my X. Lowest is 31, and then the highest one is 101. So which means I probably will not be able to start this graph using a 1, correct? So let's see, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. I can do it by tens, but you know what? Because I don't like cluster graphs, I am not going to write all the numbers, okay? So I'm going to leave one blank and write a 20, one blank and write a 40, one blank and write a 60, 80, and 100. You see what I did so that I didn't have to write all those numbers? But the first line is still 10, right? All right, what about over here? Smallest one is 75. What you need? Yes. And the biggest one is 97. So this is going to be a misleading graph because I'm definitely not going to start at 0. So I can start at 75. You're absolutely right. But then I have to make the little wiggly lines over here that says it's a misleading graph. It doesn't start on 0. This one starts on 0, the X, but not the Y. So let me see. If I have to go all the way to 97, and this is, I can start at 75, right? And then can I do that as 85, 90? No, that doesn't cover most of the graph. Can we stop talking, please? So if I do 70 over here, 75, 80, 85, 90, 95, and then 100, I only use the graph over here, and I really need to make sure that I use as much graph as I can. Can I go by what? Well, I just did it by 5s, and I didn't use the whole graph, so if I do it by 10s, it's going to be short. It's smaller. What number did I start it out with? 75. So can we start with a 70 maybe? If I start with a 70, that would be 80, that would be 90, that would be 100. 70, 75? Again, but if okay, I've already did going by 5s. 75, 80, 85, 90, 95, 100. I'm not using the whole graph. I stop in the graph there. I need to use the entire graph. So no, that's not it. Stop playing with the bottle waters, please. All right, so 75 and 3 would be 78, 81, 84, 87, 90, 93, 96, 99. So that might be my best bet. All right, so let's go ahead and do it. 75. I'm not going to write all the numbers, right? The next one will be 78, and then 80, 81. The next one will be 84, and then 87, 90 and 93, 96 and 99, and 99 and 100 and this would be 102, right? That last one will be 102. Okay, so which means that one would be 105. The top one, this one right here at the top would be 105. All right, so let's see. When x equals 31, y equals 75. There. When x equals 52, y equals 85. There. When x equals 49, y equals 83. So 49 would be somewhere over here, and then 83 there. I've done those three. When x equals 101, y equals 97. And when x equals 65, y equals 91. Okay? All right, so what's the conclusion over here? Just by looking at that line, what can I say? It's definitely a positive correlation. Very good. What would you say the R is? Closer to 1 or closer to 0.5? Closer to 1. They're pretty close. And if you want to go ahead and make the line, but I can see that they're kind of, it's not bad at all, right? So maybe somewhere over there? There? Okay? All right. What else can I say? What other generalization can I make? What can I infer based on this data? What can I infer? I can't hear. Remember, I'm wearing this. What can I infer? What can I infer? So what does that mean? Okay, it's already over there. What other thing can I infer? Yeah, because the R is closer to 1. We already have that. What is it talking about? Thank you. Give your family 50 points. The more time you study, the better your test scores will be. That's what I can infer from this data. Okay? So what is my inference? More time I study, the better my scores will be. Hmm? Yeah. Okay. Can we go ahead and come up with the line with the actual equation? Let's come up with the actual equation. So what am I asking you to do now? Go to y equal to and go to stat, right? Because I actually want the equation of that line. So I want to figure out what y equals to. You too. What do we got? 0.30x Plus what? All right, let's talk about what it means. What's my slope? 0.30. And what's my y-intercept? Okay, what does the y-intercept mean? Thank you very much. Give your family 50 points. If you don't study at all, you at least get a what? But who the heck wants a 50? It's 68, right? Now, what does your slope mean? For every what? How much does your grade go up? Per what? Per grade? Per second? Well, it doesn't say what time. I'm assuming that these are minutes, right? I'm kind of assuming that these are minutes and not hours. Right? Because that would be too much studying for one thing. That would be good studying for like, a semester or something like that, but not a one test, right? So I'm assuming that these are minutes. So for every minute that you study, your grade goes up how much? 0.30 or 0.3, right? So 1 minute, 0.3, 2 minutes, 0.6, right? 3 minutes, 0.9, and so on. Are we good? All right. Let's go to the last one. First thing. What was the first thing that I did over there on that first one? Figure out what my x and my y is. Very good. What happened? Who farted? We are recording. All right. What's my x and what's my y? What depends on what? So my thank you. The faster I go, the longer I will need to stop. If I'm driving 5 miles an hour, I won't take long to stop. But if I'm driving 75 miles an hour, then yes, I'll need longer to stop, right? So what again? I'm going to ask again. I'm going to stop because I got people talking. We still have to, we're still not knowing how to do this. We're still having a little bit of trouble with this x and this y. What depends on what? The stopping distance depends on the speed, which means your speed is your x and your stopping distance is your y. So let's go ahead and put over here speed in miles per hour because we got to label all this. And then over here would be stopping distance. In feet. All right, what was the next step I made? Before I came to I already did my x and my y, and I labeled my x and my y. Then I didn't go to stat. We got to graph it. So what was my next step? What did I do when we were doing the other one? So look for my smallest number and my biggest number so that I can figure out the scale, right? So on my x's, what's the smallest? 10, and the biggest one is 45. So we might be able to do this by fives. Let's see. 10, 15, 20, 25, 30, 35, 40, 45. Yeah, we're good. We can do it by tens. By fives, I'm sorry. All right. So this one is done by tens. But then what are my stopping distance? 27 all the way to 196. So this is definitely going to be a misleading graph. I can't start it at 0, right? So you got to do that little flash sign. Like is it the superhero, right? The little wiggly line. All right, so where can I start this? Definitely 25 because I got to go all the way to 196. So let's start it at 25, but I got to go all the way to 196. So how can I do this? By 20, so the next one will be 45? Well, if I'm waiting for people to be quiet so that I may talk. If I do 50, then that will be 50, 75, 100, 125, 175, and 200, right? That still leaves me all this junk over here. So by 10, 35, 45, 55, 65, 75, 85, that's not enough. So 25 plus 15, 40, and then 55, 95, 110, 140, 155. We're doing 15. 20 is not big enough. We already did that. All right, so how much was this one? I lost count because somebody said another number. All right, 25 plus 15. Okay, so this one would be 55, 70, 85, 85, 100, 115, 130, 145. That's not big enough. So we might need to do 20 like Brian said. So 25, 45, 65, 85, 105. That might be okay. All right, let's see. So 25, 45. I'm not going to write all the numbers. 45 and then what? 65. Then 85 and 105. 125, right? Because we're going by 20s. 125. 140. 5. 165. 180. 5. Yeah, so by 20s. And then 20 more would be 205. Yay. And 20 more, 225. All right. There you go. So by 20s. All right. 10 and 27. 15 and 44. Which one was that one? 45, right? 20 and 63. 25 and 85. 30 and 109. 35 and 136. Remember, they don't have to be perfect, right? 40 and 164. And 45 and 196. All right. What inference can I make? It's definitely a positive correlation. Positive correlation. If you had to pick an R, what would you pick for the correlation coefficient? 1. Most definitely 1. The points are pretty close by, aren't they? If I had to make a line of best fit, it would probably be there. Yay? All right. So what inference can I make? The faster I go, the longer it takes to stop. Very good. Okay. So the higher the speed, higher speeds required. Very good. More distance, more stopping distance, right? More distance, require more distance to stop, right? Yay? All right. if you had to pick an equation, some of you already did it, but that was not the purpose because you actually can take away some of these out of the way, right? Which two can I eliminate? B and D. Thank you very much because they're negatives. And the correlation is... Now is it 1 half x plus 27 or is it 5x? 5x. There you go. Yay? Yay, yay, yay? Alrighty. Yes, so this is what we're going to be doing now. I'm going to stop this darn movie.